Alright, what's up? This is Probability by Pitman, section 1.1, problem number 8. So problem number 8 is basically just number 7, but instead of using a 6-sided die, or two 6-sided die, we'll be using two arbitrary n-sided die. So with this type of problem, it really helps to draw a grid. And each side of the grid will basically represent a roll of the die. Alright, guess I thought over the words there, that's okay. Alright, so that's 1, 2, 3, 4, n, since we have an n-sided die. So we'll let x be the first die, the number roll on the first die, so 1, 2, 3, 4, all the way up to n, and then we'll do the same for y, which is the second die. So once again, x is number rolled first die, and then y is the same thing but for the second die. Oh, it's a little weird. I'll rewrite that. Alright, whatever. Let's get it. Alright, so what happens is we'll write in the grid. So 1, 1 means we rolled 1 on both the first and second die. 1, 2, 1 on the first die, 2 on the second die, and I think from there you guys can see what's going on. Alright, so once again, we have two n-sided die, it goes all the way up to nn, and it starts at 1, 1. So what we're looking for, specifically the maximum, the probability that the maximum of the two numbers rolled is less than or equal to 2. So if we look carefully at the grid, we'll see that that is really only true for this L and then this, because remember we want less than or the max to be less than or equal to 2, and that is only true when the biggest number is 2, and that is literally only true for these 4 sections. So what we can do is write, oh, let's switch that in. So what we can do is write A, so we know that there's 4 valid squares in our grid, so that's 4 as our numerator, and then we have to divide that by however many squares there are in total. So we know it's an n by n grid, so it's 4 divided by n squared. Alright, I hope that made sense. Alright, now let's do B, which is extremely similar. It's just the maximum of the two numbers rolled is less than or equal to 3. So we do literally the exact same thing, we just expand it a little. So now our L goes from 1, 3, all the way to 3, 1. So 3 is the max in all of these. 3 or less is the max in all of these. Now we still have this 2, 2, but then remember we can include these. So now we have 2, 3, 3, 2 included, because 3 is still the max. And then 3, 3 is still included, because the max can be less than or equal to 3, and it's still possible for both of them to be equal to 3. So now if we count that as 1, 2, 3, 2, so 5, plus 3, 8, then the last one, so it's 9. So then it's 9, and then once again, it's over n squared total squares. So our probability is 9 over n squared. I guess a better notation is P max x y less than or equal to 2, and then the same thing here for 3. Man, I didn't tell this hard. Yeah. Okay. So problem C, the maximum of each number rolled is exactly equal to 3. Okay, so this one's a little different. So for the max to be exactly equal to 3, it means that the square has to have 3 in it. So you'll actually notice an interesting pattern. So for this one, we have like a right side L, right? So it kind of just looks like a L we use, but for this one, it'll actually be the exact opposite. It'll be, sorry, let's get a highlighter. It'll be like this. So 1, 3, 3 is the max. 2, 3, 3 is the max again. 3, 3, 3 is still the max. 2, 3, 3 is still the max. 3, 1. So these are all the ones where 3 is evolved and 3 is still the max. So you'll notice it's like an upside down L, whereas for the other one we were using like a right side L. I guess that pattern doesn't really help when you go later on to like more than 2 dimensions, but you know it does help you conceptualize when you're only dealing with 2 random variables, x and y. So yeah, so we know there's since this has to be exactly 3, we know that there's 5 logical options. So we'll write our answer as C P max x y is equal to 3 is equal to, sorry, I think it was 5? Yeah, 5. 5 over n squared, and again n squared because we have n squared total squares within our grid. Alright, D. So repeat B and C for x instead of 3, and for each x from 1 to 6. Honestly, I'd take this as an exercise and do it yourself, because I'm kind of lazy, but you know what? How about we do it for 4? But it's a pretty simple pattern regardless. Okay, so B and C. Okay, so it's really the exact same steps we did before. So I'll just do P of max xy is equal to 4. Alright, so it's quite literally the exact same thing we did before, except we do it with 4. So 4, 1, 2, 4, 3, 4, 4, 4, 4, 3, 4, 2, 4, 1. So that equals 7. So the answer is 7 out of n squared. And you'll notice that it goes from 5 to 7. And if you do the rest, you'll notice a similar pattern of it increasing or decreasing by 2. And you can actually generalize this as a linear function if you so choose to. Alright, E. Alright, so I could do E, but honestly, just think about it logically. You're adding up 1. So if we do this for 1, it'd just be 1, right? If we're doing for 2, it'd be 3, because we'd have that L. So 1, 3, 5, 7, and then so on until whatever the nth value is, right? So if you add them all together, you'll end up with some value which is equal to n squared. So you end up with n squared, and if you do the probability, you add them all together, you get n squared, which is equal to 1. So what they're trying with E is that if you total all these together, then you're just finding the probability that it's some square within here. And since you're just finding some square, which is included in all of these, the probability will be equal to 1. I guess that's kind of a weird explanation, but I hope that made some sort of sense. Thanks, guys. This is my first video. I'm trying to study for Stat 134. I hope it wasn't too bad.